Even though Claude Code is one of the most powerful tools for AI development, why does it fall apart on certain tasks? And between the features Anthropic has been dropping recently and the workflows we've been building around it, the way you're supposed to use this thing looks completely different from a few weeks ago. Our team has been using Claude Code every day, and it's not just for development, but also for research, managing our production pipeline, and automating tasks that have nothing to do with code. So let me just show you everything that we've figured out. Anthropic recently added the Insights command for Claude Code. It analyzes all your past Claude Code sessions over a certain time period and generates a report. The report analyzes your working style, roasts your working patterns, highlights what you were doing right and what you weren't, and tells you how to improve. The main thing we were interested in was identifying where things went wrong, because that's where we can learn to improve ourselves. The report highlighted the areas where we had the most friction and also suggested features we could add to make the workflow better. For example, we remember a session where the main agent repeatedly polled the task list for a long time when we were using agent teams. It caused the session to take too long and we had to end it ourselves. To prevent this from happening in the future, we can copy this prompt into Claude.md so that whenever we're using Claude Code with multi-agents, Claude doesn't poll indefinitely and acts upon it. We can import these tips into our projects for future workflows so that our experience with Claude Code gets better over time. Our team has spent a lot of time working with Claude Code, and the most important step is still how well you give context to the agent. This can be project requirements broken down into subparts or documentation of the frameworks and libraries you're using. Because when you give it the right context, errors basically drop to zero because it knows what to act upon. For project documentation, we prefer using Claude to write it rather than doing it ourselves. We gave Claude a specific prompt that contained all the information needed to break down the project's idea into the required documents. We asked it to create 4 documents, each focused on the specific aspect of the app. The most important one is the PRD, which contains information about the project requirements and scope. Then there's architecture.md, which has data formatting, file structure, APIs, and all the architecture details written out. Then decision.md, which contains all the decisions Claude made during the creation of this project, acting as a reference for future use. And then the most important one is feature.json, which contains all the features in a specific JSON format. It has all the details about each feature in a token-efficient way and contains criteria for what makes a feature complete, along with a passes key for keeping track of what's been implemented and what hasn't. Now that your large task is split into smaller sections, we need to provide documentation on what tools it needs for implementation through the Context 7 MCP. It has documentation for all the libraries and frameworks and gets updated frequently so that agents can pull the latest docs and fill the gap between what the model knows and what actually the current update. Setting up the MCP only takes a few steps. Once installed, it uses the tools from Context 7 and fetch the library information directly. This lets it use the latest documentation, prevent code errors caused by dependency mismatches, and get a more accurate implementation. Now, hooks are another underutilized feature. The hooks in Claude Code are shell commands that fire at specific points in the lifecycle. There are many types that trigger at certain times, like session start, before any tool is used, or after a tool is used. But the most important part is setting them up with specific exit codes. The exit codes tell Claude Code whether to proceed, block, or ignore an action. An exit code of 0 means success. An exit code 2 means a blocking error. So whenever Claude tries to do something it shouldn't, it hits exit code 2, it gets an error message back and can correct itself. Any exit code other than those two is non-blocking, shown in verbose mode, and execution continues. This exit code 2 is important because using it, you can control the agent's behavior. If you've ever worked with test-driven development using Claude Code, you might have noticed that it tends to modify the tests if it fails to meet them. To prevent that, we set up a custom hook that triggers on pre-tool use. The hook protects the test scripts from modification. If the path it's trying to work on is a test directory or contains the word test, it shows an error message saying modifications to test folders are not allowed and returns exit code 2. With this hook in place, when we gave Claude a prompt to run the tests and the tests failed, it tried to modify the test files, but the script blocked it and a blocked from modification message appeared. This stopped Claude from editing files it shouldn't be editing. So if you've worked with MCPs, you know they bloat the context window. And when you're working on a large-scale project, the number of connected MCPs increases. So all the MCP tools end up living in the context window and it gets bloated. For this exact purpose, Claude Code has an experimental MCP CLI mode that solves this. We set the experimental MCP CLI flag to true. Once we set it, all the MCPs that were showing up in the context disappeared and no context window was taken up by the MCP tools. The question was how to access the tools if they don't exist in memory anymore. anymore. Instead of loading all the tool schemas up front, Claude Code uses MCP CLI info and MCP CLI calls, and it runs all the connected MCPs through these tools via bash. With the flag set, when we gave it a prompt, instead of calling the MCP tool directly, it called them via MCP CLI tools and ran them as bash commands rather than MCP tools. This way, it only loaded the required tool on demand, preventing the context bloat. Also, if you are enjoying our content, consider pressing the hype button because it helps us create more content like this and reach out to more people. Now, in our previous videos, we have stressed using Git to have all the agents' work tracked in version control. You can also revert back if the agents don't implement things correctly. We also covered a video where we used Git to run an agent on a long horizon task, which you can check out on the channel. We used parallel agents to work on different work trees so they could create all of the project's features while staying isolated from each other. This way, we could merge their output together later without interference, because agents working on the same files cause conflicts. Branches aren't preferred because they cause conflicts. Agents have difficulty checking out different branches since branches share the same working directory, but work trees don't. So we gave it a prompt where we provided multiple features that needed to be implemented and specified that each agent should work on a separate work tree. It used a separate agent for each work tree and implemented the features in isolation, even though their task descriptions overlapped at certain points. After Claude implemented all the features correctly in separate branches, we had it merge the output so we could get all the features in a single working directory. Now, strict mode is essential for shifting the burden of error checking to the agent. This is something you should be setting up for whatever language you're using because it catches bugs when you build instead of when users hit them at runtime. Since our primary language is TypeScript, we always set strict mode to true in our projects. This turns on checks for null values and implicit types, enforces strict typing and null checks, and overall means fewer runtime errors. This matters for AI agents because they don't have a built-in way to catch runtime errors. Strict mode minimizes the chance of runtime failures and makes sure the compiler handles these issues instead. Agents can rely on error logs in the terminal to apply known fixes. Instead of letting the project be tested only by scripts, there's an additional layer of testing worth adding. You write user stories that describe how the user interacts with the system in order to guide the testing process once the app is built. We actually define the user stories before implementing our projects because this sets a standard that the implementation should follow. Using a prompt, Claude wrote multiple stories inside a folder containing all the possible ways a user can interact with the system. Each story features a specific aspect of the app, its priority, and the acceptance criteria for the agent to test against. The user stories covered all possible test scenarios, including best case and edge cases. These stories basically tell the agents how to interact with the system we just built, and with the right instructions on how to interact with the system, any agent can apply the same principles to the app it's building and meet user expectations better. With the stories documented, we asked Claude to implement them one by one and prompted it to start with the optimal path listed in each story, making sure all edge cases were covered. This way, the implementation had fewer gaps and better user satisfaction overall. Now, all the tips we have been talking about are available in the form of ready-to-use templates in AI Labs Pro. For those who don't know, it's our recently launched community where you get ready-to-use templates, prompts, all the commands and skills that you can plug directly into your projects for this video and all previous ones. If you found value in what we do and want to support the channel, this is the best way to do it. Links in the description. So we need to make use of parallelization as much as we can because this is how the agent speeds up its workflow and implements things that don't need to wait on each other. We know Claude automatically detects whether a task can run in parallel or sequentially and decides on its own, but it doesn't hurt to create agents ourselves. We also covered these agent capabilities in our previous video where we talked about how you can use agents to make your workflow faster. But this speed comes at the cost of increased token usage. Still, parallelization effort is worth it. At one point, we were working on research for the impact of Opus 4.6's improvement using the same model, and it kept hallucinating facts even though we provided sources. It kept writing incorrect information, and we had to correct it repeatedly. Making this research felt pointless because we had to keep fixing things ourselves. To prevent this from happening again, we used parallel agents. We set up a research task where we wanted to compare the agent swarm capabilities of Kimi K 2.5 and Claude's agent swarm. We used two agents, one to do the research and another to fact-check the research agent. The key idea was to have both agents communicate with each other to make sure the findings were accurate, so we wouldn't have to do that ourselves. In this setup, one agent does the task while the other critically analyzes it, giving them an adversarial way of working. The research agent started first, and the fact-checker was blocked until the research agent produced the first draft. Once the first draft was done, the fact-checker started verifying it. It immediately identified many inaccuracies in the data that the research agent had listed, and we no longer had to catch them manually. Both agents kept kept communicating with each other and kept the fact-checking process tight, one agent dedicated to calling out the other on wrong information. There are many tasks you can run in an adversarial setup like this. Not just research, but development work too, where one agent implements a feature and another reviews the implementation against the plan. According to the words of Claude Code's creator, the agent works better if it has some way to verify its own work. The core idea here is giving the agent eyes, meaning the ability to check whether the implemented feature is correct and meets expectations. Because these agents are terminal-based, they can't identify issues that happen at runtime, especially on the client side. We use multiple ways to verify the agent's work. The first is the Claude Chrome extension, which provides browser-centric tools like DOM capturing, console log checking, and more. Another tool is the Puppeteer MCP. This one is useful because it runs in a separate browser that doesn't contain your existing sessions, unlike Claude's Chrome extension. It's isolated and doesn't interfere with any of your current sessions, so you get an extra layer of privacy. But our preferred option is Versal's Agent Browser. This isn't an MCP but a CLI tool that gives agents browser testing capabilities. It has tools for navigation, capturing screenshots, and more. Unlike the other tools, it doesn't navigate based just on screenshots. Instead, it uses the accessibility tree, where each element has a unique reference. This compacts the full DOM from thousands of tokens down to around 200 to 400 tokens, so it's way more context efficient. That was the main issue with the Claude Chrome extension, which the agent browser solved. It loads the entire DOM into the context window and exhausts it quickly. We also added instructions in Claude.md to have Claude rely on agent browser first before falling back to MCP-based testing. So Claude uses agent browser as the primary verification method. But there's another angle here. Testing is always important, but there's a way to reduce errors that doesn't involve tests or code reviews. We ask Claude to predict things that haven't happened yet. We ask Claude to check the implementation and identify areas where the app could fail. This works because we're giving Claude a chance to predict potential issues by pattern matching against failures that already existed in other apps, even if we haven't hit them ourselves through testing yet. It pushes Claude to look at the code from a different angle than before. When we asked it to do so, it identified critical gaps that passed even our multi-layer testing process and found 18 issues that could have been harmful in production, but our testing processes didn't catch them. They could only be identified when we pushed Claude to look at the project from another angle. That brings us to the end of this video. If you'd like to support the channel and help us keep making videos like this, you can do so by using the super thanks button below. As always, thank you for watching, and I'll see you in the next one.